Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help me promote my channel to keep me going, inspired and refreshed. Now, if my videos are important and if interesting to your studies, also please don't forget to subscribe. Analyze the rigid frame shown by slope deflection equations, then construct the shear force and bending moment diagrams as well as sketch the elastic curve. E is constant. So here is the given figure. So we have side sway and slopes at B, C, and D. So this we expect three unknowns here. This will be the expected uh, side sway configuration of the frame. So each will undergo side sway delta, which is assumed to be clockwise because of this loading. So therefore, MAB is 2 times EI 1.5 over L5 quantity 2 times 0 plus theta B minus 3 times delta over 5 minus fixed moment W12 5 square over 30. Simplifying, MAB equals zero point 0.6 theta B minus 9 over 25 delta minus 10. Call this equation 1. MBA, so it is theta that will be doubled, so MBA is 1.2 theta B minus 9 over 25 delta plus 12 5 square over 20, and MBA is equal to 1.2 theta B minus 9 over 25 delta plus 15. Call that equation 2. MBC, there's no sides way, so 2 times EI1 over L5 quantity 2 times theta B plus theta C minus 3 times 0 minus 30 times 2 times t squared over 5 squared for the fixed moment. So MBC is equal to zero point 0.8 theta B plus zero point 0.4 theta C and minus 221.6. MCB interchange coefficient 0.4 theta B plus zero point 0.8 theta C then plus 32 square 3 over 5 square. So MCB is zero point 0.4 theta B plus zero point 0.8 theta C plus 14.4. Call that equation 4. Then MCD 2 times 1 over 8 quantity 2 theta C plus theta D minus 3 times 0 minus 15 times 8 square over 12. So MCD is zero point 0.5 theta C plus zero point 0.25 theta D minus 80, equation 5. MDC, interchange coefficient 0.25 theta C plus zero point 0.5 theta D plus 80 by symmetry, and the fixed moment is positive for DC. MCE, their sidesway, so 2 times 2 over 6, 2 theta C plus 0 minus 3 delta over 6. MCE is equal to 4/3 theta C minus 1/3 of delta, equation 7. EC is E that is doubled, but theta E is 0. So this is 2/3. MEC is 2/3 of theta C minus delta over 3. Equation 8. Then MDF, there is sidesway 2 times 1 over 4 quantity 2 theta D plus 0 minus 3 times delta over 4. MDF is equal to theta D minus 3/8 of delta, equation 9, while MFD, so it is F that is doubled, but theta F is 0, so this is half. MFD is 0.5 theta D minus 3 delta over 8. So applying equilibrium equation at joint B, which is MBA plus MBC equals 0. So MBA 1.2 theta B minus 9 over 25 delta plus 15 plus MBC, which is zero point 0.8 theta B plus zero point 0.4 theta C minus 21.6 equals 0. So setting up the first equation, 2 theta B plus zero point 0.4 theta C minus 9 over 25 delta equals 6.6. Call that equation A. At C, MCB plus MCD plus MCE equals 0. So MCB is zero point 0.4 theta B plus zero point 0.8 theta C plus 14.4 plus MCD 0.5 theta C plus 0.25 theta D minus 80, then MCE plus 4 thirds theta C minus delta over 3 equals 0. So combining like terms, simplifying, setting up equation B, zero point 0.4 theta B plus 179 over 30 theta C plus 0.25 theta D minus delta over 3 equals 65.6. Call that equation B. So recalling the equations established, equations A and B, then the moment equations for DC and uh, DF. So at joint D, MDC plus MDF equals 0. So MDC plus MDF theta D minus 3 delta over 8 equals 0. So 0.25 theta C plus 1.5 theta D minus 3 delta over 8 equals negative 80, equation C. Since there are 4 unknowns, we need to establish another equation, that is by statics AX plus EX plus FX equals 0. So these are the assumed support reactions. For moments, let's just assume clockwise. Everything is clockwise. So AX plus EX plus FX plus zero point 0.5 of 5 times 12, 1 half of 5 times 12 equals 0. So A sub x plus E sub x plus Fx equals negative 30. Then if we draw the free body diagram of column AB, summation moment B, there is MBA here. Then AX times 5 plus 1 half of 5 times 12 times 5 thirds equals MAB plus MBA. So these are the assumed moments. So for AB, summation moment B equals 0, AX times 5 plus 1 half or zero point 0.5 of 5 times 12 times 5 thirds equals MAB plus MBA. Simplifying, AX is 1/5 of quantity MAB plus MBA minus 10. Substitute the value of MAB and MBA here. So AX is 1/5 of quantity MAB 0.6 theta B minus 9 over 25 delta, then minus 10 plus MBA, which is 1.2 theta B minus 9 over 25 delta plus 15, then minus 10. Simplifying, combining like terms, AX is equal to 0.36 of theta B minus 0.4144 of delta minus 9. Then for this column here, summation moment C equals 0, EX times 6 equals MEC plus MCE. Therefore, EX is 1/6 of quantity MEC plus MCE. Substitute the values of MEC and MCE. So EX is 1/6 of quantity 2/3 of theta C minus delta over 3 plus 4/3 of theta C minus delta over 3. Simplifying, E sub x equals theta C over 3 minus delta over 9. Then for FVD of this column, summation moment D equals 0, Fx times 4 equals MFC plus MDF, MFD plus MDF. Therefore, Fx is 1/4 of quantity MFD plus MDF. So substitute Fx is 1/4 of quantity uh, zero point 0.5 of theta d minus 3 delta over 8 plus theta d minus 3 delta over 8. Simplifying, Fx equals 0.375 of theta d minus 3 delta over 16. So substitute into this equation here. So we have 0.36 theta b minus 0.144 delta minus 9 plus theta c over 3 minus delta over 9 plus 0.375 theta d minus 3 delta over 16 equals negative 30. So combining like terms, simplifying, setting up equation D, 0.36 theta d plus theta c over 3 plus 0.375 theta d minus 7967 over 18,000 delta equals negative 21. Equation D. So solving equations A, B, C, and D simultaneously or using Excel or any calculator that can solve 4 simultaneous linear equations as long as it is allowed by your professor or by the board exam if you take the board exam. So we'll have theta b equals 2.2177 over EI, theta c is 33.3594 over EI, theta d is negative 51.13 over EI, and delta equals 31.053 over EI. So from here, we can compute the joint moments. MAB equals zero point 0.6 of 2.2177 minus 9 over 25 of delta minus 10. So MAB is equal to negative 19.848 kilonewton meter. MBA is 1.2 of 2.2177 minus 9 over 25 of delta plus 15. So MBA is 6.482 kilonewton meter. So that means MBC negative 6.482 kilonewton meter. MCB is zero point 0.4 of 2.2177 plus 0.8 of 33.3594 plus 14.4. MCB is 41.975 kilonewton meter. MCD is zero point 0.5 of 33.3594 plus 0.25 of theta d negative 51.13 minus 80. So MCD is negative 76.103 kilonewton meter. MCE, MDC is 0.25 of 33.3594 plus 0.5 of negative 51.13 plus 80. So MDC is 62.775 kilonewton meter. So that means that MDE is negative 62.775 kilonewton meter. So let's have the results earlier. Then we have MCE equals 4/3 of theta C minus 31.053 over 3. So MC is 34.128 kilonewton meter. MEC is 2/3 of 33.3594 minus 31.053 over 3. So MEC is 11.889 kilonewton meter. Finally, MDF equals negative 62.775 kilonewton meter, and therefore FD 0.5 of negative 51.13 minus 3 times 31.053 over 8. So MFD equals negative 37.210 kilonewton meter. For the shears and reaction, other reactions, call this AX. This is the correct direction of MAB because MAB is negative, so it is counterclockwise from the slope deflection sign convention. So MBA is clockwise, shown. So AX times 5, that's clockwise, plus MBA equals MAB AX times 5 plus MBA equals MAB plus moment of the load 1/2 of 5 times 12 times 5/3. So AX times 5 plus MBA equals MAB plus 0.5 times 5 times 12 times 5/3. So AX is equal to 12.673 kilonewtons directed as shown. Then shear just to the left of B, just to the right of B rather. So this is the moment BC, negative, so it is counterclockwise. MCB positive, so it is clockwise as shown. And this is the anticipated direction for shear just to the left. So MBC summation, considering BC summation moment C, so shear at B just to the right times 5 plus MCB, which is 41.975, equals MBC, which is 6.482 plus 482 plus moment of the load 30 times 3. So shear at B just to the right is equal to AY, which is equal to 10.901 kilonewtons. Likewise, for shear at C just to the left, summation moment B. So shear at C just to the left times 5 plus MBC, which is 6.482, equals MCB, which is 41.975 plus moment of the load 30 times 2. So shear at C just to the left is 19.099 kilonewtons. Considering CD, these are the directions for moments. So summation moment D equals 0, shear at C just to the right times 8 plus MDC, which is 62.775, equals MCD, which is 76.103 plus moment of the load 15 times 8 times 4. So shear at C just to the right is equal to 61.666 kilonewtons. So EY equals the shear at C just to the left plus shear at C just to the right. So let's have the EX and EY and the direction for MEC, which is positive, so clockwise. MCE, which is positive, so it is also clockwise. Therefore, EX should be rightward. Summation, considering CE, summation moment about C equals 0, so EX times 6 equals MEC plus MCE. Therefore, EX is 1/6 of MEC, so that's EY, 80.765 kilonewtons. So EX is 1/6 of MEC plus MCE, where MEC is 11.889 and MCE is 34.128. So EX is equal to 7.670 kilonewtons. Then for column FD, moment FD is negative, so it is counterclockwise from slope deflection sign convention. MDF is also negative, so counterclockwise. Therefore, Fx is leftward. Summation moment about D equals 0. Fx times 4 equals MFD plus MDF. Therefore, Fx is 1/4 of MFD plus MDF. So by the way, shear at D just to the left, considering CD times 8 plus MCD, which is 76.103, equals MDC, which is 62.775, plus moment of the load 15 times 8 times 4. So shear at D just to the left is equal to Fy equals 58.33 kilonewtons. Then Fx is 1/4 of quantity MFD, which is 37.21 plus MDF, which is 62.775. So Fx is equal to 24.996 kilonewtons. And this leftward. So now that we have found the reactions and shears, we can now construct the shear diagram, shear force diagram. So top fiber here, top, right, and right for this column. So for first AX, so positive AX, which is 12.673 to the left, because this is the top fiber here, 12.673, then minus 1/2 of 5 times 12, negative increasing. So we have negative 17.327. So let's have this distance later. Then shear B just to the right to B is 10.901. Then constant minus 30, so negative 19.099 constant. Then it must close there. Then shear at C just to the right is 61.666 minus 15 times 8. So we have negative 58.334. Shear at D just to the left. Then this distance is 61.666 divided by 15, 4.111. So this is 8 minus 4.111, 3.8889 meters. Then because this is the top fiber, so we have to move to the right for shear, 24.996, and it must close here. Then here, this is the top fiber, so it's going to the left, which is EX 7.67 constant, and it closes. So this is the shear force diagram, and let's derive the shear equation for AB. Let's call this W and that distance as X. So W as to X equals 12 as to 5. So W is 2.4x. Therefore, the shear equation for AB is 12.673 minus 1/2 of x times W. So 12.673 minus 1/2 of WX, where W is 2.4x. So shear AB equals 12.673 minus 1/2 of 12.4x times x, then equate to 0 to solve for x. So shear AB is 12.673 minus 1.2x squared equals 0. Solving for x, so x is 3.2497 meters, where shear is 0. So this is 3.2497, and we need the area for the construction of the bending moment diagram. So by integration, area 1 is integral from 0 to 3.2497 of shear equation 12.673 minus 1.2 x squared dx. So area 1 is 27.456 kilonewton meter. While this area which is negative is integral from 3.2497 to 5 of quantity 12.673 minus 1.2 x squared dx. So area 2 is equal to negative 14.091 kilonewton meter. So let's have the bending moment diagram construction. So first we have MAB negative 19.848. So here, then plus area 1 27.456 positive decreasing, and we'll have 7.608 plus area 2 which is negative 14.091 will give us negative 6.483. So expected 6.482. So it begins with 6.482 for portion BC, negative 6.482, then plus 10.901 times 2 straight line. So we have 15.32 minus 19.099 times 3 is negative 41.977. Then shear at C just to the right is 61 point. Moment CD is negative 76.103 plus 1 half of 4.111 times 61.666 positive decreasing. So 50.655 minus 1 half of 3.889 times 58.334 negative increasing. So we have negative 62.773 775. Expect that's fine. So negative 62.775 plus this area 24.996 times 4. So we'll get 37.211. Expected is 37.21. That's fine. Then here CE, this is the top fiber. So 34, so positive 34.128 minus this area here, which is 7.67 times 6. So we'll have negative 11.892. And the expected MEC is 11.889, so that's okay. Then for the elastic curve, that's the bending moment diagram. So this is the fiber, negative, tends to be positive, concave, negative, positive, negative, 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 positive, negative, negative, then concave up. For this portion, positive, then negative. So elastic curve, it should be approximated as shown in the figure. So that's the elastic curve. So for this